Today, we're diving into something pretty radical, an idea that could completely redefine the mathematical core of artificial intelligence. It's called Machine Gnostics. So, let me just start with a huge, and I mean huge question. What if modern AI, this entire field that's changing our world, is built on the wrong math? I know, it sounds crazy. The whole thing runs on statistics. But what if that's just the wrong tool for the job? It's a bold claim, for sure, and it's exactly what we're digging into today. To really get where we're going, we first have to understand the problem we're trying to solve. You see, for hundreds of years, statistics has been our go-to weapon against uncertainty. But in the age of AI, that old weapon is starting to show some serious cracks. You can think of the way we do AI right now as being stuck in a statistical straitjacket. First off, it needs absolutely massive datasets. That's a huge problem if you're in, say, medical research or material science, where data is scarce. It also assumes all your data points are perfectly random and independent, which, let's be honest, rarely happens in the real world. And here's the kicker. It's super fragile. A few weird data points, what we call outliers or a black swan event, can totally wreck your model. This forces us into this constant brute force struggle of cleaning and transforming our data, just trying to make it fit these old, rigid models. And hey, this isn't some new complaint. The guy who founded this whole theory, Pavel Kovanich, pointed this out decades ago. He saw this deep dissatisfaction, arguing that our old way of fighting uncertainty just wasn't cutting it anymore. Something new was needed. So, if the old map is wrong, what does the new map look like? Okay, this is where things get really fascinating. Machine Gnostics puts forward this incredible idea. What if data has its own laws of physics? It all starts with a simple but super powerful analogy. We all know our physical universe is governed by the laws of physics, right? Well, Machine Gnostics asks, what if the data universe has its own set of laws too? The laws of Gnostics. Think about it like this. To describe the cosmos, Einstein realized that the flat, simple geometry we learn in high school just wouldn't work. He needed something called Riemannian Geometry, the math of curved surfaces. Well, in the exact same way, Gnostics says that data doesn't live in a flat, simple space. It lives in a curved space, and we need a whole new geometry to navigate it. So what causes all this curvature? In physics, we know it's gravity. Mass and energy literally bend the fabric of space-time. And here, this is the mind-blowing part, in the Gistic data universe, the thing that bends space is uncertainty. It's not just random noise that we're supposed to ignore or get rid of. It is a fundamental force that actually warps the very landscape of your data. Our universe also has hard limits, right? Like the speed of light. Nothing goes faster. Gnostics shows us that data has natural boundaries too. This means one crazy outlier can't just create an infinitely wrong result. You know how in statistics, one weird number can pull your average way, way off? Well, Gnostics has these built-in guardrails, which makes it incredibly tough and robust. And finally, how do we combine individual data points to create real, useful information? In physics, there are laws for how things like energy and momentum add up. Glanotopsics has a similar law for combining data. So instead of just blindly averaging numbers, it aggregates them based on the unique, curved geometry of that data space. It's like we've discovered a fundamental law of nature, but for information itself. Okay, I know that is a seriously mind-bending theory. But what does this new physics for data actually do? What are the real-world advantages here? Well, the Gnostic advantage is that it basically flips all those old problems right on their head. Remember that statistical straitjacket? This unlocks it. You don't need a mountain of data. In fact, it shines with small datasets. You don't have to pre-process and transform your data. You just use it as is. Those outliers aren't a problem to be deleted anymore. They're welcomed and handled naturally by the system. And you don't have to assume your data fits some perfect bell curve. The result is pretty simple. You get more information from less data and with way higher accuracy. But hey, does it actually work? Let's look at the proof. This table is from a study where they tested a bunch of different methods on real, messy, historical data. Right there at number 1, with the lowest error by far, is the Gnostic estimate. Now look all the way down at number 10. That's the good old arithmetic mean, the simple average we all learned in school. The Gnostic method isn't just a little bit better, it is in a completely different league. So a theory this powerful could have just stayed hidden away in academic textbooks forever. But a real-world problem in a real research lab changed everything. This is the story of how mathematical Gnostics, the theory, became machine Gnostics, the tool anyone can use. So the story starts with Pavel Kavanik's theory, but the spark that really brought it to life came in 2022. Dr. Nirmal Parmar was researching new materials for energy storage, and he just hit a brick wall. He had very little data, and standard statistics just wasn't precise enough for what he needed. Then he stumbled upon Kavanik's work and had this breakthrough moment. What if you could combine these Gnostic principles with modern neural networks? That one single idea was the start of Machine Gnostics, which is now the world's first open-source, non-statistical AI library, built to put these incredible tools in the hands of everyone. So you can see this isn't just another new tool or a new algorithm. It's a potential revolution in how we think about data, about uncertainty, and about AI itself. And the whole philosophy behind this project is just so powerful. Laws of nature, encoded, for everyone. The goal here is to take these deep, fundamental principles inspired by physics and put them directly into the hands of developers and researchers everywhere through open source code. Ultimately, Machine Gnostics is challenging all of us to question our most basic assumptions. So the question this whole thing leaves us with is pretty simple. Are you ready to explore this new universe of data? If any of this sparked your curiosity and you want to follow the project or even dive in yourself, you totally should. You can check out their website and find Machine Gnostics on LinkedIn and Instagram. Thanks so much for tuning in.